Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter written in Swift. We've come a long ways. We're trying to run some real code, and one of the things we don't really cover enough is the print statement. In particular, if you print with a semicolon at the end of the line, it's not supposed to put a new line in, and we don't accommodate that yet. So let's take a look. All right. Well, I found an issue before we get into that. It's still print. Let's see if I can get this right there. If you do 10 print and run, it says expected start of expression. So where the colon is, it's looking for an expression. Now you're supposed to be able to just say print. So the issue is this colon, and I kind of jumped ahead to the issue. The print statement, if the next token, when it goes into the print, if the first token is end of line, then it says, oh, it's just a print with no stuff. Okay. And the issue is that we added support for multiple prints and other statements on one line with colon separating them. So really this could be a colon or an end of line. So let's make a test that demonstrates the issue and go ahead and fix that. Let's see. Oh, interesting. Why did this? Oh, it's not print with nothing. Okay. In this case, it does have an expression, so it's not an issue. Whoops, multiple empty print statements on one line. Okay, in which case this should just be a print with nothing. And same thing here. Okay, and I expect this test will fail. Xcode, you got to start running these things. Yeah, okay. Expected start of expression, so that's what we had, the other one. All right, so it's really if token equals end of line or token equals, do we call it colon? Yep. Okay, I suppose I should swap the order since that's... Okay, so if it's, yeah, if we start out at the end of this statement with no contents on the print, then we're just going to return that. All right, and this should pass. Okay. Colon should terminate empty print, just like end of line does. Now, let's go ahead and do print. Well, let's check print with semicolon. Oh, that's really an interpreter thing, I guess. Well, it's both. Now, I guess I'm wondering how we want to handle this new line. So we could throw it in to the print, but I think that creates some issue. Let's go to the interpreter, and maybe it shouldn't matter, but we basically take the expressions in the thing and join them with spaces, but really don't want a space before the new line. All right, so I think what I want to do I'd like to change the print. It's hard to know what's the right way here. But I'm thinking, let's put a Boolean on it. Meaning, should you do a new line at the end? And we'll default it to true, and then make that always work. Oops, did I mean bool? I'm sure I did. Okay, yeah, we got a few places where we create prints. Okay, well, should you print the new line? Yes, this ends with a colon. Okay, values. Well, we're going to hard code it to true for now. Okay. Try values. Print new line. Well, let's ignore it for now. Okay. And I think tests should have some issues. It doesn't like to build those until okay, print ba-bum, ba-bum. Print true. Okay. Since these are prints with no terminating semicolon, we know that's going to be okay. I don't know. We're paying a little price here because we got so many places that use print to tell us if anything's actually happening, you know. This is parser. And unfortunately, I can't specify a default in a enum like that. Now, all tests should pass since we only ever use true and the interpreter doesn't look at it, so it shouldn't care. Good. All right, so add argument to print, telling whether to print final new line. Okay, and now let's see. I want to pass this in. Let should print new line. Let's pass that in here. Oh, really? You can't guess which one of my do prints would be the one I want. Go to if dim. Do print, and it takes should print new line, a Boolean. I just don't know. I mean, usually Booleans are not a good thing to be passing around. But well, I think we can see if should print new line, then print it. Okay. And again, this is just bubbling in something that we always use. The alternative is I put the expression in, I make a new line constant, and then I guess I have to check, like I'd have to check and see if it was in there and decide whether that final space went in before it, I guess. That seems really clunky too. Now maybe that implicit space is a problem. I don't know. But okay, test. Did you run? Okay, and really, I guess I jumped ahead a little, I guess. Let's go back to the parser. And let's make a parser test. Here's some prints. I think I had earlier. Okay. Test print. Okay. All right. Okay, so check statements. We expect print, nothing, false. Okay. Oh. Oops. Print false. Should fail. Okay. 10.7 expected start of expression. Right, because it doesn't know about semicolons yet. I mean, we had the token, I believe. Let's make sure of that. Token. Ooh, maybe we don't. Semi not found. Okay, well, let's do a Lexer test. Although, I mean, yeah, I think, do I really need to? And really, this is all driven by this table. So I think we will, let's get token again. Okay, colon, semicolon. And we'll add that here. Okay, I think this will fail the same. It's still not knowing what to do with that semicolon, but it should find it. Okay, start of expression. Yeah, so let's go to the parser. Probably close these and parser. Okay, so it says it's not a colon or an end of line. That's true. So it's going to call expression. Well, that's not really quite right either. All right, let's go to our grammar. To do print fails. Okay, we've addressed that one. Okay, now make trailing semicolon suppress new line on print. Okay, the deal is you don't have to have any expressions before this semicolon. Okay, where's our grammar? Print. Okay. Print. All right, I guess I should put the word grammar in here. Expression factor number variable. Oh, we didn't really. Oh, we didn't really do statements, did we? Unless, oh, that's up here. Oh, I already had grammar in there. Okay. This loop stuff's a little bit of, it's not a grammar, but up here it is. Okay, print expression optional. Okay, that's really not enough. All right, so I'm going to change this to print statement. Goes to that print statement. Okay, so really, well, the full-blown maybe I should just say what the full-blown thing is. So you're allowed to do this. Print x equals x. Okay, no separator is required. If you put a comma, then you're saying go to the next tab stop when you print the next thing. So it would print. This would print something like x equals 3. I think we get the automatic space, and then maybe the tab stop to 10 or something. Y equals 4. Okay, and you can print a semicolon and print something else. Well, that just gives you a separation of a little minimal separation. The original basic, it would do tab stops of 3, and most of the following basics just put them as close as possible. Okay, and if I do that, then the whole thing is, the next print is going to start at the end of this one. Okay. So this expression, it's really, well, one thing is you can have multiple expressions. So it it could be expression star would be a step forward. I mean, that would let us do x equals x, y equals y, and so on. But no commas and semicolons. But really what it is, expression or comma or semicolon star. I think that's more accurate. Now, the only thing funny in that, I don't, it's like, is this legal? Well, I think it kind of is. So it's like, how do we want to put these in? I mean, somehow, well, commas and semicolons can't be part of expression. We know that. They've got to be separate because a semicolon is just not a valid expression in most other contexts. Okay, so I could see putting something in. Well, let's go to our parse. Statement, print expression. I mean, it could be possible that I've got to distinguish the expression tree node from the expression syntactic construct. So the expression tree node, I think I could make a case for putting those in here. And where like a semicolon is like a thin space and a tab, or the comma is a tab or something like that. That these would become sort of well, they'd be kind of entities, standalone entities. I don't know. It's a little funny because they're not real expressions. I just don't know. I mean, a print, he wants to say expressions. I could put another layer in that's like, printable. And one case would be expression, and one case would be, thin space. Another would be tab. Would that be good? And it's like only for the support of this one statement. So it's a trade-off. Like maybe I'd be better off with expressions. And if you evaluate, well, let's see. What happens if you evaluate an expression? So let's find evaluate. Is that it? Evaluate. Returns a value. The problem is, would you be able to put this in a normal expression? Maybe not. Like, okay, so this is where I think the grammar is separating things. So because expression here is not going to match commas and semicolons, these expressions will never be formed with those being a possibility. So evaluate of them, it doesn't mean anything. I mean, it won't happen on an expression, on an arithmetic kind of thing, because the grammar won't allow you to put them in there. So maybe that's okay. And so my proposal is make thin space and tab space be new expression types, and then maybe that has to boil down to value as well. and evaluate just returns the value for that. I don't know. I think that would work. So let's do it. I could probably boil it down to one case. Like, again, a Boolean. But it could be spacing with Boolean to tell you if it's fat. I don't know. Is that a good thing or not? The problem is to put this in, I have to touch a lot. I've got to deal with types and values and everything else around it. Where if I put it in a new level, it affects the print more. Let's see how that goes. Okay, so public enum printable. And the cases are thin space, tab space, and expression. That's probably less in impact. Let's put it in. We'll comment out these two. So we're going to do this. I'm going to back this out for a minute. And this is one of these refactoring to make space kind of things. Or Kent Beck has a great quote that's like, to make a hard change, first make the change easy, warning this could be hard, then make the change. Okay, so we're going to try and make it easy to put a printable in here for prints, and then interpreter is going to have to deal with it and stuff like that. But let's make this change on print that it's going to print printables. Okay, and people are going to complain it won't build. Okay. This value, okay, values that append, this is going to be dot expression of value. And values type is now printable. Okay. And then is this interpreter? Yeah. So values on do print. Oh, come on. Really? Values should be printable. Okay. Map format. Well, let's see what format does. Oh, come on. Format prints an expression. Now tabs, I don't know. We're gonna have some fun with that. How's it gonna format a tab? I don't see how it can. Okay, so map format. I'm going to map let's make it printable. Takes a item that is printable, returns a string, I guess. Okay. And we're going to call that did format just take one expression? Okay. The bulk of it. Okay. So this is switch item case expression expr let expr and return format of expr. Must have at least one. Yeah. Try. Okay, so we've only got one case possible on printable right now, just expression. So we're directing the call to just call the format and be done with it. I don't think this is going to hold up when we get to our spacing stuff, but let's deal with it. Okay. Should pass. Is that, oh, test it. Oh dear. Oh, I don't see a way around this on this one. We touching every print again. All right, what can we do? Excuse me, the thing is the arrays cannot be mixed types. So if we want to be able to put these new things in, we have to be explicit here. And I will say, expression all spelled out feels clunky to me. Let's go find it. I'm going to shorten it to expr. It's such a common abbreviation when you're doing this stuff that I think it's legit. We'll let it go. Okay. Now, okay, I'm going to change my mind here. Instead of all these, let's make a little helper. Check error. Function number of okay. Where's one of these expression ones? Okay, yeah. So let's just make this be number 10, number 20. And did I do anything yet? Return dot expression dot number of number. I just don't want to get buried in these. Okay, only the prints change because they're printables. A string, we're going to have to do this. What was that? Oh, this whole thing has to be expert. I'm messing something up. Expert. There we go. Okay. Print. Again, .expert. Computer defined. I don't know. Expression. Oh. Okay. Oh, these are still dot numbers. Okay. Introduce printable. Okay. All right. So now let's take our test, bring our test back. Parser tests. Okay. This should be a failing test still because we don't accept it yet. All right. So now I think we have to add the possibility of a semicolon, which I'll call thin space. Which is really maybe no space. I don't know. We'll have to see. Let's see. So somebody's going to complain about this. Yes. Here, okay, so we'll just add case thin space. And then let's throw, where's our errors? Yeah, let's do something like this. Not implemented. Not yet implemented. Cannot find name. Item hasn't got a line number. We'll use 0 for now. I'm just trying to get out of the case. All right. Okay, that's fine. Let's go back here. Okay, now we're ready to touch parser. Okay, so here, this value, right? We really have to. This is the point where we're trying to do expression or semicolon or colon or comma. We don't handle comma yet, but let's allow it. So, I think we have an expression start. What's this method? Factor. I could have sworn we had this. What I thought was we had a method that would say if the next character could be an expression, then do something. But I'm not seeing it. So I think, all right. Where's my print? Okay, so what we're saying here, I think we want to do something like while token is not colon and not end of line, then do these appends basically. So let's try that. While token is not a colon and token is not an end of line, then we're going to do something. Well, what we want to do, let's pull values up. This is going to go in the loop. Okay, so this while is the star bit. It's the repeat. So today we only allow expressions. All right, so we're gonna look for an expression and append its value here. Okay, and then if the token is a colon, well, we know it is one of those at this point. So this is really if values dot count is 0, then we just have a print by itself. We didn't match any expressions, so a print by itself is just a new line. Okay, I think this is the same for everybody except, well, it doesn't deal with semicolons. Okay. Right, so everything else passed. Good. All right. But now we only want to try expression if it's not a semicolon or a comma, but that's okay. So if token is semicolon, then we're going to do something. Else, we're just going to assume it's an expression. Okay. And again, so we're trying to get to this. And well, values dot append dot thin space. Okay. So if we do match a semicolon, we have to consume it. And append the thin space. Otherwise, we try value is expression and append the expression. Okay, so I think this will pass. What do I know? Oh, that new line bit. Okay, so it doesn't suppress the new line. We don't get a false out because we never get a false out. So the question is, when should you have a false? Well, usually it's a true, but if values dot last, which must exist because the count's not 0, it's if it's not a thin space, okay. If it's not a thin space, then we get a true. If it is a thin space, we get a false. All right. Okay. Do I have that backwards? What the heck? Printable print statement false. Oh, okay. Yeah, that's true. We should have a thin space here. Okay. And false. Yeah, that's what we should expect. Okay. And support for parsing semicolon in print. Now, we want to do the interpreter side. Okay, because remember our interpreter just doesn't do anything with it. All right, so interpreter test. Let's find a simple print. Print. Oh, here's some prints. Okay, yeah, that's fine. Function test print with semicolon suppresses line, new line. Okay. if we print semicolon, we expect to get nothing. Okay, and I'm still chewing on this, the value we have, that map and format and all that stuff. I don't think it's going to sustain, but let's get this first. Can't happen. All right, that's what we expected. All right, what we expect, I think, a thin space is really an empty string. Okay, you're just going to put it as close as you can. Where I'm not quite clear, there should be spaces in some cases. The number, where basic format is, the numbers, I don't know. This goes back to the original paper here. Okay, this is like the original basic. Print integer something or other. Oh, rand is in here. Okay. Yeah, so the semicolon here is a relatively short space. I think this is the one, yeah. Not sure what we got there. Running it twice looks like it's the same stream to me. Okay. But anyway, they're printed close together. I think that's supposed to be 3 spaces between them. That's that one, but this one, this one's ambiguous. It just says supports the format. Let's see, this one. On the Commodore 64, the print is just like this massive thing. Okay. Logical screen, 8 print zones of 10 spaces each. A comma causes the value to be in the next zone. Semicolon causes it to be printed directly. Numeric items are followed by an extra space. Positive numbers have a space preceding them. Like, what the heck? So I don't think we're quite matching anybody's approach yet with this separator space. But that's okay. This test should pass now. Yay. Okay, so print supports semicolon is true. And I guess the more interesting thing from our perspective, a semicolon at the end forces that flag to get set so we don't print the new line. Okay. Well, I think that means we should try and run again. I've got this basic program. We'll have to chop out some stuff, but let's run it and see what happens. Okay, so I just paste it, and I probably need to go to a fixed font. I'm not sure if that is. Sorry about the mic. All right. I know I don't care about line 10 and 20. They got this tab thing. We don't support it. So just typing the line number deletes the line. 10, 20. Then 30 is okay. 100, we're just going to say H equals 10. W V equals 12. Okay, so I'm going to overwrite that line because we don't support input. Okay, and then line 110, dim W H, we said 10, 12, dim V0, 10, 12. Okay. Now the rest of this to here looks good. I don't know. I'm hoping we get to line 190 and print some stuff. The rest of this, I don't know what's going to happen. But I think syntactically we might be okay. All right, so let's do a list. Oh, there it is. Okay. All right, and let's do a run. This is just throwing big stuff at it and see what happens. Something's likely to fall apart, but oh, okay. Something's happening here. Alrighty. Again, I think maybe the font, if I made a fixed width font, it might be better. There may be some problems, but I think that's what's going on. All right, let's do something. So, I mean, this is very cool. We're getting something maze-like, even if it can't quite work right. Let's go to REPL. No, content view. Text field, scroll view text. I think I can say font. Is there a fixed? No. Font. System. Style is, oh. Okay, I'm gonna have to look it up. I think I can just put courier in quotes. Font. Oh, well, this is more like what I want. System. I don't know where that, oh, design. Design : monospaced. Font system. Oh, okay, let's do this. Size 18, say. Design : monospaced. Okay. Oh, that's much better. Okay. Get rid of 10, get rid of 20. 100, H equals 10, V equals 12. 110, dim W, 10, 12. Dim V0, 10, 12. Run. All right, I'm gonna have to get this go to bottom thing going, but it works. Woohoo! Okay, so over here's the entrance, right? And you can go through the maze. Dead end. Dead end. I don't know. I guess I can't quite see if it. Oh, entrance here. This is more promising. I don't know. Is it legit? Yeah. Yeah. It's legit. Okay. Very, very cool. Well, that's a great place to get. You can still, because I had to retype some lines and, override them and stuff. It's not quite 100% there, but I think it's good. And then I don't know, where's those eyes coming out? Let's see, are they anywhere up here too? No. I definitely want to try. Let's do this. 1011 print. Let's go to a vertical bar. And then 1030. Looks like 2 spaces. Okay, and run. Oh, that's really nice. And notice it came out different. Okay, this one, the entry point was at 2 from the right, and this one it is the right. Okay, so it is the random numbers doing something as well. It's not really working correctly, so let's capture some of that. Should be repeatable, something like that. Okay, it's kind of complicated, but it's doable. All right, yeah. Well, we're due for a break, so we'll take a break. But this is a big milestone for us. We've taken a pretty massive program and got it working, and looking really good for what it is. I don't know, those colons, are they? Yeah, they're a little weird, aren't they? But it kind of serves. They could almost be plus signs, would maybe look better. But then you have them on the ends of stretches too. Okay. Anyway, let's take our break, and we will come back, and I don't know, we'll pick up on something. I think we've got plenty of things that we can address, so we'll do that. So make trailing semicolons suppress. We've done that. I think it's a big milestone. Run amazing and get a maze, although with some tweaks. All right. That's a really cool thing. Then I think I want to bounce out and just address a couple of things. One is I just ran across this not yet implemented message somewhere in the Lexer, and it should really be unexpected character at this point. And then the other one is I started to do this the other day and got jammed up and did some research, and I think we can make the REPL scroll to the bottom. If you notice when I was doing this, I was typing and wasn't seeing it, and it should act like a console real. Okay. And then semicolon not supported in print. We did that, so that's okay. Doesn't support the tab function. I don't want to make that the top of my list. The print is clearly a big mess. Oh, but we do support print with multiple expressions now as kind of a consequence of what we did earlier. Let's make sure that has a test. I think it should pass, but let's be explicitly testing it. Okay. Print with multiple expressions. All right, and if we say 25 print 3, oh, interesting. 3 and x, okay. That, well, maybe more interesting is, I think this will work. X will default to 0, so that'll be okay. And we expect x equals 0, new line. I think we support these simple strings now too. Apparently not. X equals 0, new line is not equal to. Oh, right. Yeah, space in front. That is what we're specifying at this point. Okay. A little odd, but aligned with sort of what the C64 was doing, because it's it's not a negative number, so gets a space. All right. Okay, so that to do is done. All right, and then print with semicolon end of line doesn't print new line. Okay, doesn't move after printing values. I think we've done this. Has no space between items. Okay, that sort of falls out of what we did. Okay, so I think we'll take these. No space between strings. Yeah, I don't know if that's quite true. Okay, print with multiple expressions. That is done. Okay. Make sure everything runs. All right. Word. Okay, yeah, those are all things we found. All right, let's find this thing. Lexer tests. Oh, okay. Yeah, I want this to say error unexpected characters. Maybe unexpected character. Okay. This is, we try and match the next token. If it's not one of our listed tokens and it's not a number, string, or variable, then we're going to say unexpected character. Okay, so I think this stuff is all print. This is Lexer. Okay, I think that's a better way to say what we did today. Get some tweaks. Okay. Right. So this one, let's find this page. I think scroll view reader is what we want. Oops. I've lost my chat window. No. Oh, here he is. Okay, let's pull this out. Okay, so scroll view reader provides programmatic scrolling. Okay. So we have this proxy, and it's got a scroll to bottom button. When you hit the button, an empty text with an ID on it, and reference it that way. So let's borrow this. We'll wrap this around our scroll view. In content view, okay, proxy in that. Okay, and notice it's letting you reference proxy. Okay, so then we'll add a text empty dot ID. I think you just make this name up. Yep. ID is bottom. Failed to produce diagnostic. Cannot produce bottom ID. Oh. Dear. Output conform to equatable. Output. Oh, I think we can make that happen. I think it'll offer to do it, right? Yes. Okay. They're the same if output, well, LHS equals RHS. Oh, sorry, LHS dot output. Okay. Let's run this. Not looking so good so far. Boom. Okay. Well, that's our tab not supported. Oh, maybe that's not a big deal. That's not graceful, but it doesn't tell if this is working. The fact that it didn't scroll here, though, worries me that I'm not getting what I want. All right, let's do this again. I'm going to get rid of that offending line. Line 10, line 20. Now run. It's not doing it. Okay. wish I understood why not. Is nothing printing? This is not changing. It's never being called. I'm not sure what's up. So I would have thought this would trigger whenever output changed. Okay. Let's go look at output. I don't know if this is where I have to notify myself. I have to do the notifying, but I thought the point of published was that took care of it. I don't know. We went through this before. Sort tables. All right, so we have observed object, dependency on a reference type conforming to observable object. That describes our situation. I don't know if I have cancel in here. No. There is a... We did this in sort tables somewhere. Yeah. So we set up these cancelables. We have this published, and then when do we change those? Right, when we added a table, insert. So this basically forces it to send when we added a table. Okay, and active tables. Yeah, I think maybe we have to do this kind of thing. I never quite understood why, because it seems like the published is supposed to make that happen, but Fact is, we definitely needed it. Okay, so we do this. But our output gets in the output. That's what confuses me, because it seems like it seems like it's working. That's the part that bugs me, but I guess, I mean, it's not fully working. All right, so there, and then the cancelables, we put this stuff in. Active tables was a published field. Right. And I think it may be that, like, it's much more prepared to deal with primitive types than others. Any console absurd output dot object will change into self object will change dot send. Value of type string has no member. So that's not going to work. I thought marking it published gave it that. That's why I'm confused. Let's do a broader search for this. That didn't help. What exactly? Oh, I'm not going to watch a video. Okay. Cheat sheet. Well, I don't think that's an example. No. Yeah, I just don't know. I don't think it's adding anything, and it's clearly not supported on this object. maybe I can break here. Tempting way too much for me to track. Too much stuff. Okay. Let's let it go. We'll come back around. I'll do some more research and see if I can find something that makes this work. It seems like it should just about be an option on the scroll view. Maybe I should look there. Use proxy scroll to anchor to perform scrolling. No, that's very similar. Mm-hmm. Well, okay, I'm not seeing it. I think this works no worse than what we have, and it may be on the way towards something better. Let's make sure this isn't the issue. Nope. Okay. I don't know. Okay, let's take that out. We commit attempted to add scroll to bottom. Okay, well, let's move on. We'll just mention that we tried it. Okay, let's do this. Okay, so dim should allow multiple declarations. Dim should allow expressions. All right. Grammar-wise, dim variable. Well, this whole thing. I guess it repeats, comma, and then all this. And this should be expression. So these should too. Okay. Oh, okay. Let's just go to dim and make that work. Let's do the expressions first. Okay, parse. Dim name int. Yeah. Okay, let's go find it. Okay, this is not quite. Yeah, we'll do the expression. So we don't require an integer. But what do we do with the expressions? Well, I think parse is not sophisticated enough. I think our parse needs to be returning a list of these. So let's work the consequences of that. I think I have to parenthesize this. Okay, so you return triples, an array of triples. Oh. I don't want to do that. Let's make this an array of dim info. I may have to make it equatable. All right, who's going to break? All right, let's give this a constructor. All right. Then this is a dim info. No, that's not going to work. All right, let's push. Where's do dim again? Let's push this inside. Oh man. No, let's undo. Okay, I'm just trying to get through in kind of a naive way. Dim now takes an array. Oh, dim info. I think the test should all pass. Okay. So make dim allow for multiple arrays at once. Okay, we don't support it, but we at least have something. Okay, now an interpreter. Okay. almost want to make do dim take the array. All right. Let's go to parser. Dim info. Okay. Well, I think all this, we get past the dim token, and then we get the array name, left parend, all this stuff, right parend. I feel like we could extract a method here. Well, what do I know? We'll copy it. I'm going to call it dim1. It might throw returns a dim info. Okay, so get the variable require and then here that's this stuff. Okay, so my proposal is try dim1, okay, which should be the same as all this stuff. And then this should just return dim1, dim info. Skip the dim, do all this stuff. All right, let's see how that looks. Okay, let's add let's add this test dim with multiple arrays. We expect to see a dim with a dim info Z12. Type is number. Let's mix these just to prove we can. Three, four. This should fail. Extra characters at end of line. Yep, because the comma is not expected yet. Okay, I think we'll take another quick break, maybe just a couple of minutes, and come back and get this thing, make it support allowing the commas and all that stuff. So see you in like 2 minutes. All right, welcome back. Okay, so we have to do the multiple dimensions. Let's capture a result of array of dim info. Okay, and we always, well, we'll return result. Result depend dim info. All right. While the token is a comma, we're going to repeat that stuff. Well, it's more or less this. We have to skip past the comma and capture that and append the result. Okay, I think that should do it. What do I know? Dim info Z23, tape number, W tire. Z dimensions 1, 2. Z 2, 3. Oh, we have to add one. That's right. So when you say Z sub 1, 2, you're really saying 0, 1 and 0, 1, 2. So the size has to be one bigger. And this is 4, 5. Okay. So we allow multiple array definitions in a single dim statement. Okay, and that seems okay here. I guess, was that the runtime that had to do the make up its own in the interpreter? Yeah. I could really see dodim taking an array, but okay. I think we committed, right? Okay. Alrighty. So now we want to make it handle expressions. Okay, so we did this. Should allow multiple declarations. Okay. Should allow expressions in dimensions. Yes. Well, we haven't dealt with actually we haven't finished the multiple dimensions. We don't have an interpreter test for it. Okay. Okay, so I think we're going to say for multiple arrays. Global B. Let's make this 1. And so he gets 2 numbers. Okay. This test should fail. First part should be okay. No, it didn't. Xcode, come on, man. All right, unexpectedly found nil. Yes, that I can believe, because B never got declared. Okay, and that comes down to our dim. Dim. Yeah, so we pull out the first one, but we don't pull out the rest. Okay, so really we need to run through all the dim infos. Dim infos dot for each. Okay, and well, name is $0.name. We're calling $0 the item that we're being iterated over. Oops. Try. These are no longer needed because we're pulling them from this. Okay. Run this. Good. All right. Support multiple arrays in dim statement. Interpreter side. And let's see, so I want to look at parser again. All right, so now we want to allow expressions. And let's see, where's dim? Okay. Here's our dim statement. Really, it's dim1. So I think this type is probably wrong. Yeah, so we've assumed it's going to be integer dimensions and always only integers. But now we're saying it should be expressions. And the reason we know it's expressions is because we have this here. Like it's using H and V that it read in off the input to do it. So they're dynamic values, and there's nothing wrong with that. All right, so parser. Okay, so instead of this integer and these dimensions, unfortunately, I think this is going to have to change dim again. Okay, so dim info, it assumes integers, but it's really expressions. And maybe yeah, that's gonna have to change. They're down here, right? Expression. Okay. I don't know the order. Maybe expression should come before enumerable, before statement. Okay, so you define expression, then you define dim info, then statement, printable, probably comes before statement. Okay, so dimensions int, we're gonna have to make that expression. Expression. So we're going to get this working with expression the way it is now, and then allow it to parse fancier expressions. All right, and anybody who cares about this is going to complain about it. Okay, can't convert dimensions. Well, let's make this expression. Okay, now well, I think we can make it a number. Size +1, is that going to work? Can I convert a value of type int to expected argument? Sure. Okay. Do dim, let's take expressions. Okay. Reduce 1 star. Yeah, that's just not going to be good. Okay, this is the interpreter. All right, let's see who else is. Let's just get the type straight. Right to int expected. Yeah, that goes away. Array of int. Well, it's got to be an array of expression. And count is a number. Does it want to float there? He's value of type int to expected type expression. Well, it's repeating. Oh, it's Okay. Operator on SIMD requires it to conform to SIMD. Okay. Dimensions dot reduce. Well, okay. Array of dimensions. Array of value. Can we... Let's see, what do we do for multiply? All right, let's try it. So we're going to reduce number 1 with operators 2 sub times. Convert value to value to expected argument type value expressions as value. Okay. Well, okay. So I think what we have to do is evaluate the expressions. Yeah. Let's take dimensions dot map, and we're going to evaluate $0 in the globals context. Okay. And then this can be dimension values. Reduce 1 star like it was. And this can be dimension values. Evaluate. Okay. Calc and throw. Well, maybe it's got to be one more level here. Dimension values is array of value, right? Okay, we want dimension values to be as float. Okay. Now, call can throw. Do I need this one then? Okay. Now that's all fine. But this has to be throws. Call can throw, but the error is not handled. Okay. Yes. Now these things. This throws, but we have a couple that don't. Okay. Everybody should pass. Oh, we got in tests. Can it convert value of int to expected? Okay, so this is a number. So we had to make these expressions. And I don't know, this sort of indicates like, yeah, it might have been better to do this earlier. All right. Make dot dim use array of expression, evaluate it in interpreter. Okay. And we're still missing a piece there. We don't parse it yet. Okay. So let's get a test for that. Okay, if you did that, we expect a dim. It's got a dim info. Variable z, number. The number is 2 times 3 plus 1, 7. It wouldn't even hurt us to do that. Missing argument for parameter. Well, we're not done yet. Okay, and the type is number. Okay, one failure. Base statement missing right parend. Okay, yeah, so we were looking for a right parend after the 2 and didn't get it. All right. Yeah, so here, this integer really should be the expression. So in this case, so we want to say let expert equal try expression. Okay. And then we don't need this anymore. We don't expect an integer to be forced. And we're just going to pass the expression in here. And same thing here. Dimensions.append expr. All right, so we look for a left parend, we look for one expression, we look for comma followed by more expressions, and all we do is accumulate expressions into the dimensions. Okay, and that should work. Oh. Sub 2. Did we... I feel like I forgot something in my parser. Did we add a 1 in there or something? Sure enough. Okay. Same thing there, right? Okay. Oh, that's going to change all those assertions, isn't it? Ugh. All right. Well, we're going to pick up there tomorrow. I guess we'll have some red tests to show us what to do first. Yeah, I don't know. We need that number bigger. Maybe not. Maybe they should be lower and we deal with it on the other side. Okay. We'll decide that tomorrow. Anyway, tomorrow will be Friday and We'll be doing it at the usual time, 10 a.m. Eastern Time to 12:30 p.m. or 3 to 5:30 p.m. UTC. Thanks for joining me, and I hope I catch you in the future. Take care. Bye-bye.